This is lesson 68 of the Quantum Mechanics, a mini lecture series calculating quantum probabilities. So I'm going to show you how to calculate the probabilities of specific quantum states. So suppose we have a quantum state given by the following: psi is equal to 3i basis state 0 plus 4 basis state 1. Okay, and this is based in a two-dimensional state space because you have two basis states, 0 and 1. Now, for this to be a legitimate quantum state, we need to ensure that the probabilities for each basis state adds to 1. Okay, let's see. So to find the probability of each probability amplitude for each basis state, we take the absolute value squared, right? So the coefficient of basis state 0 is 3i, and the coefficient for the basis state 1 is 4. So let's work out the probability amplitude of the 3i. Absolute value squared, you get, so I is the square root of -1. I squared is just -1. Okay, the square root of -1 times the square root of -1 is -1. So you have 3 times 3 squared, which is 9, times -1, which is -9. Absolute value of that is just 9. Similarly, absolute value 4 squared is just 16. So we find in this case, if you add these two up, you'll get 25, which is not equal to 1. So to find, we find that the total probability is 25, which is impossible. So how do we go about rectifying this? We need to what's called normalize this quantum state by taking the square root of 25 and dividing each component, the 3i and the 4, by the square root of 25, and take the modulus squared as we did before. So here's what we do. 3i, so the square root of 25 is 5. Okay, so we're dividing. If I take psi, rewrite it again like this. Plus 4 divided by 5, 1. Now if we take the probabilities of each component squared, that'll give us 9 over 25, which is 0.36. Absolute value 4/5 squared will give us 16 over 25, which is 0.64. Now, if you add these two up, you'll get 1, okay, which now makes sense, okay? So we can therefore rewrite our initial quantum state as follows, and that's how you find probabilities of particular quantum states, probability amplitudes for coefficients of basis states, just using this method here.